Our second problem is a disc of mass 2.0 kilogram and radius of 60.0 centimeters, in which we convert to meters, and which will give us 0.60 meters, with a small mass of 0.050 kilogram attached at the edge, is rotating at 2.0 revolutions per second. The small mass suddenly separates from the disk. What is the disk final rotation rate? So we gather the data. Since we have two masses, will be M1, which is the disk, and M2, which is the small mass of 0.0 kilogram, and the radius, which will be 0.60 meters, and the revolutions, which will be 2.0 revolutions per second. And we find angular. We use the formula angular momentum, which will be impulse. Since we have two objects, we use impulse 1 plus impulse 2 times angular speed, which will be exactly the total amount of impulse times angular speed. To find impulse 1, we use the formula half mass times radius square, which will give us 0.36 kilograms times meter square. And since it's a disk, to find impulse 2 of the small mass, we use the formula m times radius square, which will give us 0.018 kilograms times meter square. Since it's asking what is the disk final rotation rate, is basically angular speed, so we isolate this formula to find angular speed. We put L to divide, and we put, since this is multiplying, we pass it here, this has to divide. So this will give us 2.1 revolutions per second. That will be the angular speed, and that will be the final rotation rate of the disk.